Alright guys, welcome to this page of the notes, and what we're doing is we're still working on that first objective or learning target, but now we're going to switch to solving exponential inequalities using the common logarithm. And the reason we need to use the common logarithm is this. I've got a great example problem here where the base is a 3 and my other base is a 7. And there's no easy way, there's no way to rewrite these bases so that they're the same with integer exponents, right? There's no way to do that. So what we're going to have to do, like we did in the previous problems, is we're going to have to take the common log of both sides, and then we'll see what happens. So let's do that. I'll take the common log of 3 to the 5y power less than the common log of 7 to the y minus 2 power. Well, again, right away, just like we did in the previous problems, I recognize that now what I have is the power property for logarithms, where those powers can now be brought down out front and multiplied as coefficients. So let's do that. That means I'll now have 5y times the log of 3 is less than y minus 2 times the log of 7, common log of 7. Okay, well, the next step here is going to be, because this is a quantity, I'll need to distribute the log 7 through the parentheses. So we'll wind up with 5y times the common log of 3 is less than y times the common log of 7 minus 2 times the common log of 7. All right, now, keep in mind what we're trying to do, right? We're trying to solve this exponential inequality for y, right? We're trying to solve for y. That means I need to get the y by itself. I need to isolate it and get it by itself on either side of the inequality. Well, I have a y here, and I have a y over here. So in order to isolate the y's, I'm going to have to get them grouped together on the same side of the inequality. I think probably the easiest way to do it would be to just subtract this y, common log of 7, to the other side. So I will then have 5y, common log of 3, minus y, common log of 7, is less than negative 2, common log of 7. All right, let me slide over a little bit so that you guys can see the rest of my work. Here's what we're going to do. I'll slide over and move up. I have, right, this guy, 5y, common log of 3, minus the y, common log of 7. Well, what do both of these terms have in common? They both have a y in them, right? I have a y here and a y here. So I'm going to factor out that y and leave the rest. So here we go. I'm going to factor out that y. So I'll have a y, and what's left over is the 5, sorry, that looks like an S, is the 5 times the common log of 3 minus the common log of 7, right? Because I pulled the y out of this guy, and I pulled the y out of this guy. I factored out their GC, out their greatest common factor, which was y, so there it is. That's what's left over when I pull out that y. And it's all going to be less than the negative log, I'm sorry, I forgot my 2, I apologize. Minus 2, common log of 7. Okay, well, here we go. In order to get this y by itself, since this is multiplication, I'll divide this whole quantity to the other side, and so we wind up with y is equal to minus 2 log, common log of 7, divided by all of this stuff, which is 5 times the common log of 3 minus the common log of 7. But there's a little bit more that we can do here, right? Some properties of exponents apply. First of all, this 5, this coefficient, well, I can use the power property of logarithms going the opposite direction to make it the exponent on the 3. Also, I have subtraction down here, which means I can use the quotient property of logarithms to rewrite this guy as a quotient. So, what you're looking for as your final answer simplified, oh actually, nope, scratch that. I can also in the top take that coefficient of 2 and make it the power on the 7. So I'm going to have minus log of 49, right, because 7 squared is 49, all divided by the log of, now the 3, right, that 5 becomes the power on the 3, and then I'm going to use the minus sign to give me the quotient property, so 3 to the 5th power divided by 7. Again, if you wanted to, you could then go ahead and plug all this into your calculator. Negative common log of 49 divided by the common logarithm of 3 to the 5th divided by 7. If you did that, you get a decimal approximation, which is about negative 1.09. And so I wind up with, I apologize, I am so sorry, scratch that. I accidentally swapped my inequality for an equal sign. Please don't do that. It's less than. And so I wind up with y is less than negative 1.09 as my solution. All right, definitely a little bit longer problem when you're dealing with the inequalities, but the same method applies. We'll take the common logarithm of both sides, and then from there, it's just grouping the y's, group the variable on the same side. It'll be your GCF that you can pull out. We'll try a couple more so that you get the hang of these. Here's another one. I got this one. We're going to solve 5 to the 3y power is less than 8 to the y minus 1 power. All right, well, we know there's no way to rewrite 5 and 8 so that they're the same base, at least not with integer exponents. So let's go ahead and take the common log of both sides. I will have the log of 5 to the 3y less than the common log of 8 raised to the y minus 1 power. Again, the power property of logarithms will allow you to bring those guys down out front. So 3y log of 5 less than the quantity y minus 1 times the log, common log of 8. Distribute that common log of 8 through the parentheses. So I wind up with y times the common log of 8 minus the common log of 8, right? Because it'd be the common log of 8 times 1, but 1 times anything is just that number. All right, here we go. I need to get the y's by themselves. I got to isolate on the same side, so we'll subtract the y common log of 8 to the other side. Great, we're doing good. Now I've got my y's on the same side of the inequality. It's all less than negative common log of 8. Because the y is the GCF in both of those terms, I can pull that y out as a GCF. So let's go ahead and do that right over here. Just let me come up over here so you guys can see the rest of my work. All right, so I'm going to pull that y out. And that's going to leave me then with, when I pull the y out, let's see, hang on a second, what did I have? I had, okay, so I'm going to have 3 common log of 5 minus the common log of 8. So here we go. I'll be left with 3 times the common log of 5 minus the common log of 8. That's what's left over when I pull out the GCF, which is my y. And that's all less than the negative common log of 8. Well, to get the y by itself, divide this quantity to the other side. This time I won't lose my inequality symbol. Y is less than negative common log of 8, all divided by 3 times the common log of 5 minus the common log of 8. And just like in the last problem, I've got some simplifying that I can do. There's nothing I can do in the top because my coefficient is a 1, and there's, right, that's already an 8 to the first power. But that 3, all right, I can take that 3 and make it a power on my 5. And again, I have subtraction, which means I can write it as a quotient. So here we go. Y is less than negative common log of 8 divided by the common log of 5 to the third, all divided by 8. That is going to be your most simplified form. That's going to be your most simplified form. And again, that is approximately, if you were to use a calculator, it comes out to be a negative 0.756. Negative 0.756. All right, again, I know these problems are kind of complicated. There's a whole lot of algebra going on here, but again, it's algebra you should be comfortable with. We use the distributive property. We factored out a GCF. We combine like terms. We simplify, right? That's all stuff we've been doing forever in algebra. It's just now you got to do it with exponentials and logarithms. But that's what happens in algebra. We keep teaching you new stuff based on old skills. So let's do one more. Hopefully by the time you get to the end of this one, you may even have gone on and done this one yourself and are just coming back to check your answer. That's fantastic. There's no way to rewrite 3 and 6 so it's the same base, so we take the log of both sides. Common log of both sides, which is immediately going to leave me with the power property of logarithms. So I bring those powers down as coefficients out front. 2x common log of 3 greater than or equal to the quantity x plus 1 times the common log of 6. Distribute that common log of 6 through the parentheses. 2x times the common log of 3 is greater than or equal to x times the common log of 6 plus the common log of 6, because 1 times anything is just itself. I'll need to subtract this x common log of 6 to the other side to get my x's together so that I can then factor it. 2x times the common log of 3 minus x common log of 6 is all greater than the common log of 6. Great, now that I've got them together, I can factor out my GCF, which is going to be an x. That's going to leave me with 2 times the common log of 3 minus the common log of 6, which is all greater than the log of 6. Let me slide up a little bit so you can see the rest of my work. Here we go. We've been here before. To get that x by itself, because it's multiplication, divide that whole quantity to the other side, and we're going to simplify. So x is greater than or equal to the log, common log of 6, all divided by 2 times the common log of 3 minus the common log of 6. And we simplify using our properties of exponents. There's nothing I can do in the top, but in the bottom, this 2 will become the power on the 3, and the subtraction means I rewrite it as a quotient. So it'll be a 3 squared, which would be a 9 divided by 6. That's as simplified as it gets, and if you were to plug that into your calculator, you should get 4.42. All right, guys, so when it comes to these problems, we're going to use that common logarithm to help us solve exponential inequalities where there's no way to rewrite the bases to integer exponents so that the bases are the same. We'll just take a common log of both sides and then quite a bit of algebra to get yourself down to a simplified answer, and even plug that into your calculator to get a decimal if I were to ask you for it. All right, what we'll do on the next page of the notes is move on to that second objective or learning target where we look at the change of base formula. So head on over to the next page. I'll meet you guys there.